We are excited to have Arash Marzban. He's a Senior VP of Product at StackPath. He's going to be sharing with us how edge computing and serverless can provide better customer experiences. Arash, we're excited. Floor is yours.
Awesome. Thank you. Thank you, everyone, for joining. Excited to talk to you guys a bit about edge computing and what we're doing in the space and how we think things are changing and evolving. So let's jump right in. So just a quick little background. My name is Arash Marzban. As Max mentioned, I help run kind of the day-to-day product management at StackPath. I've got a background in data analytics, kind of product management, security. I've been in a couple of different really interesting companies and startups in my career. And I've been really excited as we've embarked on this vision for building an edge at StackPath. And that's what I'll share with you guys today. So, where we kind of tackle all of this is around the edge being infrastructure that ultimately allows an application to run much closer to an end user than a traditional or centralized cloud. And ultimately what that translates to is speed, security, and efficiency in the process and application delivery, where latency sensitive workloads can really shine. And the way we view it is that you're going to have different use cases that really apply to the edge. As we kind of walk through today's presentation, we'll cover a number of those different use cases. And some are really interesting, and there are future ones to be had. And a big part of that is how application design and architecture is likely going to change over the next several years as developers start to take advantage of what the edge can really provide and balance the use of traditional clouds with edge in order to deliver the best experience for end users. So let's talk about why the edge matters to kind of set that stage. So our viewpoint has always been that realistically, public clouds are phenomenal. Every company on the planet at this point uses the public cloud in some way or another. But there's really some changes in how we consume content, how we engage with applications, and the quality of rich digital experiences that we're looking for or want are really starting to change the dynamics of network design, of where compute needs to live on application architecture. And applications are becoming more complex and end user demands are becoming higher. And there are a number of things that have changed in the industry just in the near term, just with the pandemic as well as the emergence of 5G, that are really driving a call it a pivot in what's really required of platforms in order to be effective. So when we look at it, one of the items that's just fascinating to me is the new kind of call it connectivity at the edge, right? And that's with things like 5G. So as 5G and emerging cell technologies continue to burgeon, what we're going to really see is a movement of transit from being kind of edge to core, where an application or a person makes a request of something and that traverses the entire network back to the core cloud, and then the application will respond with data or video or content. And it's going to move towards really sitting across the edge of the network. And this shift in network architecture, where the requests and action really happens, is going to be driven by the fact that new technology is going to enable a different perspective on how networks are designed, where the majority of the bandwidth sits, and then in collaboration with where does the application sit and how does it work. And so 5G really enables us to see lower latency, greater density, and it all traverses again the edge of the network. And it's just a really interesting technological kind of change or shift that is going to, I think, enable edge computing to continue growing at a rate even faster than before. And we've seen with the pandemic just these big shifts and cycle changes in how people do work. When you look at applications or platforms like Zoom and how much they grew from number of daily participants over the past year or so, it's a huge shift, and it's really quite fascinating when you think about it. And I know everyone who's here today has probably experienced the change in what it's like to work remote and dialing into things and the tech challenges and everything from stutter to lapse to everything else that comes into play are all really interesting problems that we now have that we didn't have because we weren't all using Zoom 24 hours a day to communicate. And that's not going to change. So we really think that this trend is likely to stay on track for quite a while. So, just a little while ago, there was this great kind of overview of employees, people just like all of us who were working or may have not worked remote prior to the pandemic, but really based on how companies have changed their policies and how people have adapted to working remote, we really see almost a 20% change in employees who are likely to work remote with either always or with great frequency as the pandemic hopefully comes to a close. And this represents a really big change. So the connectivity to the home, the ability to deliver video, content, applications in highly distributed ways where latency and quality of the application delivery and experience matter are going to have a profound difference on how and when applications start to move towards edge computing. So this is further kind of supported by just the general growth we've seen. As all of us dial into the latest and greatest TV show or connect our home thermostats to the internet, or as we've seen a lot of news recently in the security space. So attacks on pipelines, attacks on supply chain, these types of attacks from a security standpoint are only increasing in frequency and volume. And so there are just a number of inherent values to having your application architecture in a highly distributed environment like the edge, and then being able to secure it with additional protection and enhancements. Those really make a big difference to still being able to deliver your solution stack, your products to market when you know that they're highly distributed and less prone to impact from security risk. So we're here because we strongly believe that the solution to all of these challenges really resides at the edge of the network, right? Which is, let's say, the edge of the cloud, or what's going to be the new edge of the cloud. And the way we describe this is pretty straightforward, but we've got a great map I want to take everyone through. So if you think about a user who sits behind a device, whether that be a computer or a cell phone or tablet, the reality is every request gets served pretty much from a centralized data center. And so as we look at it, those computing resources sit pretty far away. It's not just one hop away. And there are lots of steps that data has to move through, whether it's the request or the response, in order to deliver on what we as users and consumers ask for or leverage. So if we look at this from different angles, the real edge is going to be the first device that your tablet or phone or PC or desktop or TV hits when it makes the request. But of course, that's a very limited environment with a very small device. So gateways, as we all know, don't have a ton of power. So maybe in the future they might, and you might have data and applications living there. But let's look at it a little bit more pragmatically, which is the reality is you want to be close to that ultimate edge in order to deliver effectively and efficiently. And in every use case, there's different sort of edges. So it might be an access point, or you might have in the context of a connected car, that ultimate edge is really the cell tower that the LTE or 5G modem connects to, or the 6G modem when it's integrated into cars. And as we look at that process, what we really start to see is that there really are a number of different edges, if you will. And the one we've all been really familiar with, obviously, has been cloud and enterprise edge, where we all have workloads and applications running in. The layer above that is the internet edge. And what we've traditionally seen is CDN providers and others operating out of this environment because it provides lower latency, a greater proximity to end users. But the edge extends beyond that. And our vision really focuses on telco data centers, central offices, data huts, and even the cell tower as being the next layer and evolution in edge computing. And this is where it starts to get really interesting, because as edge evolves and the application architecture changes, if you look right to left on this map, you're really going to start to see, okay, well, how do I spin up workloads that really span these environments? And how do I do that efficiently and ensure that my platform and service delivers with an exceptionally high quality, because I want my customers to have a great experience using my product, my service, my application. And that's where functions come into play. And and really the application architecture starts to look at different deployment methodologies. So serverless, when we talk about it, means a couple of different things. Of course, there's just script-based changes, content, things that you might use to modify a stream as it's getting to the end user. And that's one application for serverless. But it can also be, a container that has no, noted, or I should say, no accessible compute instance behind it. And that's where container-based workloads, where you're not worried about the operating system or the back end of the platform, and you're really focused on what code am I deploying and what is that code going to do, those enable a really effective and efficient migration of application components to the edge. So the further to the left you go, the smaller the component or chunk that you want to deliver and build around. So let's dive into kind of how all of that translates into platform and services and value and what we can see as users as we leverage the edge. So there are a number of critical benefits or key benefits that go with edge computing in general. Latency is obviously one of the critical ones. The closer you are to the end user, the more responsive any application, whether it be video, gaming, kind of a mixed use experience, is going to be. If you're doing analytics like digital dynamic ad insertion, and you're trying to make decisions on the fly on what advertising to embed and deliver to a customer, the edge provides faster response time than any other platform, just for a number of physical reasons. But of course, geographic control and security, the distributed nature of edge, all creates these really interesting advantages that allows us in the community to be able to define variables like, where's our application going to deliver data, where is it going to store it, when is it going to respond, and how do I segment my ecosystem or geography to respond differently. So if I'm building the next great, let's say, financial platform and service, and I need to manage what data can traverse my network or where it can live and whose information gets managed where and how do I respond to it, the edge is really the platform that gives you the granular control to be able to do that. And ultimately, this really comes down to a higher quality of service, better data responsiveness, support for things like regulatory and compliance differences between different geographies, globally. And ultimately, as you combine the concept of sort of managing the decision and response engine component of any application with, hey, I've just got some data, I've got to store it somewhere. So you really start to look at balancing what workloads you have in public cloud and what those look like versus the workloads and applications that traverse into the edge. And that's where you get to start to see some really what is ultimately going to be a lower cost, because you can deliver at a higher level of performance closer without having to try to kind of balance that out with greater performance on the compute side or platform. So it becomes a really interesting dynamic of how do I leverage that proximity and the lower latency to offset some of my standardized compute costs and move it to edge while I'm getting a better experience. So these values ultimately result in some use cases that I thought we could share with everyone on the call today. So, when we really look at delivering content, right? The core challenge is always going to be things like gaming, right? Gaming or video. And so let's talk about a gaming use case here. That ultimately you really just need a simple, dependable platform that a centralized cloud can't offer. And best effort delivery just isn't going to work in those cases. And so, one of the approaches is you go build your own network, you go build your own platform. And that's both cost prohibitive and extremely expensive to undertake. But when you have a public cloud edge like StackPath does, the ability to leverage our core infrastructure to orchestrate around, deploy workloads, deliver services, really then enables companies whose core proficiency is application development or services delivery or development to be able to build their app stack on top of StackPath. So, with one of these use cases, a customer was able to pick up workloads that they already had in public cloud and weren't getting the performance they wanted out of it, and move those to the edge, enabling them to ultimately deliver a higher quality experience with lower jitter, lower latency, lower packet loss than they were able to do out of public cloud. And this is just a simple lift and shift exercise. This isn't even necessarily taking on where the edge is moving, which is building applications in an edge native way. And what that means is that you really start thinking through your application architecture and you say, okay, if part one or one component of my application works and does these things, for example, it takes the request from the customer, it analyzes it, and it responds. Well, that component of my application is likely going to do much better living and running at the edge. But occasionally that piece may need to go back to a central cloud or another data center in order for it to respond to another layer or take a different action. And so by having a really smart linkage, which the network design of an edge provider like StackPath does, is that the community has to look at and say, if my app lives at the edge, but a part of it also may live centrally, how do I ensure the highest quality of experience? And that's in the interconnects between the core cloud and the edge, which is a critical component of how we believe the edge is really starting to grow and blossom. Another use case is really then around how do I deliver managing or delivering content. And so if you think about the traditional CDN providers that live in the internet exchanges, so if we go back to our map of what the edge looks like and the different points on that map, well, managing your content side by side with your ability to manage users, manage your viewers, manage your application stack, and you can do both your video delivery as well as your application stack and response in one place, you're going to have a phenomenal customer experience at the end of the day. And so, a use case here was someone coming in and we're having challenges with viewers tampering with URLs to try to get to paid content, which is, of course, it's going to happen. And it's a big problem for everyone who's protecting their IP. And enabling someone to take their content, store it within our core platform and deliver that, but also then leverage the fact that you can run your security and user verification stack in the same location and lock down content and manage it becomes a really interesting use case. And it helps bring more of the traditional workflows that had to be segmented across multiple environments into one unified infrastructure that enables you to store, deliver, and respond without having to traverse the network. And ultimately, that's where the massive savings comes into play from latency. So, CDNs have existed for a long time where everyone's tried to push content to the edge. But now if the application can sit right next to a CDN and deliver content as well as manage users and the application layer that goes with it, again, the end user experience changes pretty drastically in that. So how does all this get accomplished? Companies that are tackling the edge ultimately really have to look at the edge being a platform. And what's really interesting in all of this is that if you look at how the physical infrastructure and exposed computing, virtualized computing layers and networking come into play, and how those bubble up into applications, there's a piece that has to orchestrate all of that. So a unified control plane with common APIs where if I'm in the DevOps group, I can easily pick those up and automate around them. But if I'm a developer, I can also pick the right, kind of call it performance and targets that I have for my application, and I can orchestrate those across the globe. That platform view is critical to being able to do that. And where the edge really starts to differ is that the edge isn't necessarily competitive with public clouds. There is a place, and there will be continued massive growth in public cloud usage. Every company in the world leverages public clouds in some way or another. And so if you look at the edge and where it really fits in is that the key to edge is about being agnostic. And the way we view that is that the edge is a great place to drive orchestration, to drive delivery, to drive decision making, but it's always going to need to interface with clouds. And over the past several years, as many of us have seen, there's been a really big shift towards a multi-cloud ecosystem where services have to run across multiple platforms, where one provider provides, let's say great security, another has great analytics tooling, and another has great scalability. And you have to make these decisions as you're looking at these different providers and figure out, okay, well, where does this workload sit and where does that one sit? The edge provides a great way to actually be able to reach back into every cloud provider, regardless of how many clouds you're running, and orchestrate your stack deliver your applications, and to do it in a way that is very transparent to the end user and is simplified. So the agnostic nature of the edge is a really, really big piece of this, and it's not ever meant to be competitive. It's meant to be an additive supporting item to your centralized workloads in public cloud. Modularity for us, when we look at that, platforms have to be able to be deployed, and where there were, let's say, 100 or 150 critical internet exchanges that really are a great spot for any CDN provider to live out of. When you think about edge computing, the view is that it has to be even further distributed than that. So it's not 100 locations, but as edge computing footprints grow, we really think it's hundreds, thousands, and even tens of thousands of locations down to cell towers, where computing really has to extend that deep and that close to end users to really provide the ability for application architecture to take advantage of this tiered. I can run a bigger part of my application centralized, and the higher performance critical ones I can move closer to end users and provide a better experience. So modularity enables a company and a platform to traverse these different steps within the edge. And ultimately, regardless of it being broad, it's got to be hyperscale and it's got to be secure, as we've seen again time and time again when we read the news every morning. So let's look at what comprises that platform stack. And so if you take the physical infrastructure and you think of it as my bare metal and my storage devices and networking and my egress or bandwidth, the first consumable layer of that is really edge computing. So I can jump onto a platform and consume virtual machines, or leverage serverless functions, or kick off my storage capabilities, or even do create virtual private clouds that span edge to core cloud. So that's my first interaction layer. But the layer that a lot of us focus on is always around delivery and security, and even how am I routing and managing and monitoring my platform. And the edge is a great place for any application to sit, whether it be applications that StackPath provides or your app stack. Another way to look at the application layer at the edge is, if I'm an appliance vendor and I've created a security appliance that has to typically sit on premise for it to be effective, well, the coolest part about the edge is that I could take that application and I can virtualize it. And since it can sit just one or two hops away from my physical location, I can still deliver an extremely high quality of service with almost all of the same benefits of having it sitting proximal or right inside my network. And if you add that physical infrastructure layer and how that bubbles into sort of virtualized networking, for example, it really then allows you to build the linkages between my location, my edge, and my public cloud. And these are really interesting kind of outcomes that having this multi-layer approach to edge, I think, provides the market and application developers. And ultimately, footprint's a big part of that. So StackPath, when we look at our footprint, I'll kind of share what we do from that standpoint. We've really targeted key areas that content and applications and services get delivered out of. And it is immediately typically more diverse than a standard or centralized cloud. But as edge continues to grow, and we take that concept of modularity and go further into the service provider footprint and down to the cell towers, you can imagine a map like this being filled with dots globally. And so how you orchestrate your workloads and deploy them and manage them all comes back into the same concept that we have for our platform and the edge engine concept that you saw earlier, which is, how do I really move data and how do I move my applications into every region, and then how do I control that, and how do I ensure that they're delivering at the highest quality of service? So edge computing ultimately comes down to a few key items. So I just kind of want to highlight those for everyone. So as we've talked about it, edge computing really delivers what is ultra low latency, and both in time to spin up a, let's say, virtual machine or service, and to response. And ultimately, what that means is that any application you put on the edge, it becomes more effective pretty much immediately. A great use case for this is a lot of really cool new technology around gaming platforms. So everyone from Microsoft to Google and several others have built new services, including Amazon, that are sort of these true cloud gaming platforms where I don't need to have a console sitting inside my home, but I can effectively spin up a game and I can play it remotely. And so in that scenario, latency matters. Where my gaming, my gaming platform was connected to my TV in my living room. Now it's not. Now my screen is really acting like almost like a virtual desktop to the gaming platform itself. And so the edge inherently enables these types of scenarios that didn't exist before. And it can do that by bridging across clouds and having the right scalability and flexibility to support that process. So we've talked about some of these use cases, but I think they're really pretty interesting. So we've talked low latency quite a bit. The software defined appliances I mentioned just a moment ago, but this creates a new world in which a number of providers that have built great technology that had to run on premise can now actually port and deliver their applications and services at the edge. And that creates a completely new ecosystem of, call it X as a service, being delivered to whether it be businesses or consumers or whoever it might be. And this is again one of the key advantages. And the more distributed the edge is, the better decision making and tool, let's really call it a number of different tools in the toolbox that the application development community and architects and businesses can start to look at and say, where can my platform run? Where can my application run? Where does it make the most sense? And what am I really trying to solve for my customers? And what new business models can I create from it? And of course, one that goes without, it goes without saying, but it's, I think, important for us to touch on is private edge applications. So if we take the context of 5G being a big driver and businesses or enterprises wanting to build sort of their own edge, being able to take the modularity of a platform and putting it into any location and then connecting those locations over transmission standard like 5G enables companies to really stand up infrastructure and connectivity in a way that wasn't possible before. So you're no longer running fiber to every location. You're not worrying about what's my transit, my bandwidth. You're really looking at, where do I want my platform to operate? Where do I want my compute capability? And if I can connect it wirelessly, that really gives you the ability to scale unlike before. So the business or the enterprise edge stands to gain a lot. And if you're taking a private 5G network and leveraging a compute platform like StackPath, the sky is the limit for what you can design, and the time to implement and deploy a solution like that really starts to shine in the age of edge, if that makes sense. So containers are obviously a major part of that, and so we talk about this concept of how serverless can really drive what is a different experience, a higher quality experience, because developers in the community at large can really then focus on what am I going to build? What's my application going to do? And that's where the majority of R&D investment ultimately goes. So the orchestration piece and the agnostic nature of edge, bring us back to the concept of if the edge overlays every public cloud, every kind of centralized platform, how should I be thinking about building my next application, right? And that is, I have to really focus on, if I use something like Kubernetes, let's say, right, or I'm using containers for my application, well, that gives me the ability to orchestrate that workload, those applications, all the way from the edge down back into public cloud and across different regions and locations. And so, going with a serverless capability like containers or even serverless functions really then enables you to be able to spread out the application, deploy it and manage it and scale it up and down depending on user demand at the end of the day. And it also enables, of course, control that we've seen with the shift into the container kind of workflow, which is your workloads can be temporary, they're non-persistent. This also makes them less prone to attack because you can always you can always tear down from a security sense. You can tear down a container and you can rebuild it instantly from your original image. And these microservices are just more efficient to run because you're just spinning them up to respond and then they go away. And so the scalability and burstability that you get with distributed applications or structured applications that are cut up to run into containers effectively really gives you that massive advantage in that process. So our view is, the edge is built to really support an ecosystem that is application focused, where the server shouldn't matter as much. If you want to lift and shift, that's great. That is what the VM kind of platform is there for and enables. But really, as we think about that concept of building edge native, you really are looking at the agnostic nature of edge, the orchestration capabilities that you get with edge as a part of a multi-cloud scenario, and you build on top of that. So let's talk about some of those other applications that I mentioned in the platform view. So edge is synonymous in some cases with CDN. Now, we don't view it that way. There's a lot of kind of marketing out there that will say a CDN provider is an edge company. The reality from our view has always been that CDN is an excellent and key application for the edge. And that really comes down to a platform that enables the reduction in latency and improves delivery. And there's some key aspects to that. Obviously, you accelerate content with the CDN, and you improve end user kind of experience in that process. And whether you're doing CDN delivery on a website or an e-commerce site or on video delivery, it is always going to be about proximity to end users. And with the edge approach and platform approach that we think is the way forward for computing, what really I think end users are going to get to see out of this, or users are going to get to see, is that the CDN can traverse, and you can actually have multiple layers of caching as opposed to just caching at the internet exchange. And so better, richer end user experiences where you've got highly available content extremely close to the end user, content that is not as frequently accessed a little bit further away. But even in that umbrella, we're talking about multitudes of performance higher than centralized delivery. And the same goes for large file delivery. I know every time I plug in my iPhone, I have an update on it, or my watch. And so, how quickly I can download that update my device and run with it, or whether it be a new game or service or platform, these are all really, really valuable kind of, call it outcomes that delivery allows you to do. And the way we look at our stack is that when you've got the right infrastructure and the right computing layer, then any application can run on top of that stack. So whether you're using StackPath CDN or you spin up your own CDN on top of infrastructure at the edge, those both become synonymous, and it's all around app delivery enabled or powered by the fact that the edge cloud is available. So CDNs deliver a lot of value inherently when we look at it, everything from speed and performance, the visibility that goes with how do you really understand what was delivered and how was it delivered and how do you orchestrate around it. And ultimately, this helps do a couple of things. Is that on the video delivery side, at a minimum, we know that for all of us, patience is key, and the market has changed, as we saw with what's happened with the pandemic in both video growth as well as kind of what I would call mixed application environments where you have both video and chat, and it's a two-way platform. So by enabling a higher quality of service that is closer to end users, ultimately it reduces everything from customer pain to cost of service deployments and outages and issues. And the more distributed that environment, the less prone to pain it always is. So none of this is complete without security. And we kind of talked about security in the platform vision. And when we look at use cases where security is critical, protecting your content, protecting your application are paramount. And again, time and time again, when we open up the news, we see everything from pipeline attacks to supply chain. And those are really, I don't want to say avoidable, but it's difficult to address. And the edge provides an opportunity for bringing or pushing security so far or so close to either where someone is entering the network or someone's making a request that you really start to add, call it, different boundaries of protection in that process. And so for many years inside security, there's been this concept of zero trust. And the concept with zero trust is if you're not supposed to access my platform or content, I'm going to block you from the get-go. I'm going to keep you out of my environment. And it's been really difficult to implement it because controlling it and having the devices in the right places and knowing how to configure those can be exceptionally complicated and time consuming. But when you're talking about dynamic application protection and content protection, when you run your security stack at the edge, this really becomes the first time in history where we can really talk effectively about building a zero trust layer or a zero trust concept into your infrastructure. And you do that by doing it at the edge of the network, which is agnostic to and overlays every other application or centralized data center platform globally. And in that process ultimately enables a level of security that has been hard to accomplish otherwise. And we also think that we talk about user experience, a better outcome, right, as a part of this discussion. The better the quality of security and the less intrusive it is to end users, the better the experience. And to do that, you have to have products that are really easy to configure. And when your computing and your security and your delivery all sit at the very edge of the network, you really gain the ability to orchestrate across these three services and make sure they're configured properly to deliver the best end user experience. So it's a really, really key part of the whole component. So I'll keep going on this one, and we'll talk about kind of serverless scripting, which is a really big part of the edge in general. And it allows you to do a couple of different things. One is when you think about delivery, it's around extensibility. So if I want to modify content, I want to modify images, video, a file that's being downloaded, or I want to convert content, serverless is a great place to do that. And by running it at the edge, you get what is a really lightweight application and response engine that allows you to modify and tweak and change data in ways that can really improve the end user experience. So just like when we looked at containers and really doing a container that isn't tied back into compute platform or VMs, you look at serverless in the exact same way, which is I'm going to run bigger parts of my application in containers, not worry about the servers that are running underneath them, and then the parts that are quick and responsive that I just want to spin up for a millisecond to take an action or make a change, I can do that via serverless. And so if I wanted to build an authentication engine, serverless is a phenomenal place to do that and leverage. And so having that as part of the edge platform for us is a way to enable customers to be able to authenticate a user and then turn the service down without having to have it be persistent, which makes it more prone to attack in that process too. Or if I'm creating an API gateway, or if I'm converting and optimizing images, these are all functions and activities that are part of almost every experience that we have as we interact with the internet day to day. And being able to do that at the edge of the network in a highly responsive way, but also have the power of containers and the power of VMs sitting there, really enables you to think about your application architecture completely differently. And when you tie those into what we call edge applications like CDN, then you're really looking at what is a holistic ecosystem of services and tools where you can solve almost any problem you need to at a faster rate and a higher quality than other outcomes. So this translates into true distribution of that serverless script globally, better performance and deployment, control over what gets deployed where and how it responds. And ultimately, all of these things help reduce cost versus trying to run a heavy workload, and especially if you're trying to run it centralized. I mentioned a little earlier that every edge platform, no matter how you look at it, especially when it's agnostic, has to tie back into a central, call it a central platform or a central cloud. And whether that be your data centers or your services that are already existing or public cloud, the ability to direct connect to the edge and move data across those layers and drive responsiveness becomes a really key value of edge computing platforms in general. So when you're moving large traffic volumes, you've got a lot of content, whether that be video or software delivery or gaming download use cases, the ability to link and move things between the edge and central cloud is critical in all of this. And the same thing when you think about CDN, for example. So under the guise of content delivery, the frequency of origin calls and data being able to go back and forth if you're refreshing your cache is really interesting as well. And so direct connectivity from that standpoint enables better consistency and reliability when you want to push data to the edge. All right, so I know we're almost right at our question mark. So I'd love to answer any questions that the audience might have, whether that be about the edge or where the edge is going or what the edge means or anything else.
Awesome, Arash. We do have a couple of questions, and obviously encourage the attendees, if you do have a question, go ahead and drop it in the Q&A section, and we'll get to them as they come through. One of the questions that came in were, what are the gotchas? You know, like in cloud, when you move to the cloud, if you didn't optimize your cloud environment properly, your costs can go from $400 a month to $40K a month. What are some gotchas in Edge?
That's a really great question. So, you know, I think everyone I've spoken to at some point or another has tried to understand the cost of cloud computing, and oftentimes, you know, there are these kind of marketing buzzwords like shadow IT and other things that people use that are pretty creative and clever titles. But it comes down to, how am I using the environment? And ultimately, if you're using cloud, the key value in cloud is scalability. I can put my application in and I can scale it up and down. The key value for Edge is really performance. And so the gotcha, if you will, is I, as a application developer or architect, want to really look at understanding what my app stack looks like, what services live where. And I think so long as you really take a close look at, you know, what component of your application lives in cloud versus what's going to live at the edge, that's the piece that will enable you to get the most value without kind of getting into the gotcha, right? Which is, I moved a lot of stuff to the edge, and man, like the edge, the performance is great, but you know, I'm incurring expense, and it's the same thing that happened to me when I tried to do cloud. It's really around just smart planning of what components matter and which ones don't. And one of the best ways to do this is really look at the platform architecture or service architecture and say, what's doing the response versus what's doing the data storage, right? And you know, later analysis. If you've got massive data stores, public cloud is probably the right place to put those. But once you train, and I'll use AI and ML as a great example from that, right? If I want to build, if I want to do my ML, I might want to put that on a central area, right? Massive data set. I want to train my models. I want to, you know, analyze it. Well, that's great, but there's a place where I need to take that ML and put it into action, right? Because I've trained the model. I want to now I want to make my platform intelligent. I want it to respond to things. Well, I'm really going to run the AI component of that AI ML concept at the edge. And you know, that's one kind of way to look at it. And if you look at around any application, that you're gonna think about it the same way. If I'm doing, you know, just boorish transcode and I want to store 10 different, you know, files, central cloud's probably pretty good for that. If I want to do, you know, conversion on the fly and delivery and response based on platform and screen, I'll probably want to do that kind of stuff at the edge of the network. So these are the things to think about as you look at, okay, what's the gotcha for cloud? What's the gotcha for edge? Really focus on cloud as being an area for scalability, and the edge is really being an area for performance.
Awesome. Thank you. We got another one that came in that actually kind of goes off of something that you were bringing up, and they were talking about where are companies leveraging the edge with ML? And so you were kind of going in there, but can you expand on that a little bit, like maybe some of the actual industries or some companies that are using it?
Yeah, it's also another great question. I have a tendency to call every question great because I actually do think they're awesome. So this is a really interesting one where let's use a use case. You know, smart doorbells like Ring is an excellent example of a company and a platform that ultimately benefits from technologies like the edge. So when I come up to a Ring doorbell and I press the button, what's really happening at a high level is, hey, it's starting to record video or capture something. It's going back to a centralized server somewhere on the internet to decide, okay, a human showed up. Is it a human? Is it not? And then I'm going to create a linkage between that doorbell back to the end user through the central cloud. So like I'll pick up my phone and I'll be able to see who's on the screen. And when you look at a use case like that in the application, there's AI and ML built into these doorbells, these intelligent doorbells. One of the things that they do is they record motion, they capture they capture, oh, a car drove by, or a human walked by, or I saw a dog, or whatever it might be. And and so the ability to respond quickly in those scenarios where the doorbells is, or the smart device, this IoT device is intelligent, this is a great use case where edge computing really helps improve the performance of something as simple as as an intelligent doorbell. So I may train my platform, my ML centrally, because I'm going to collect data from thousands of doorbells. I'm going to parse and analyze those images and run it through a neural network. But then when it comes time for the actual product to work for the end user, then I want my stack running at the edge, because then when Sally shows up at my door, or Jim does, or whoever it might be, and rings my doorbell, and I get there's a human being standing at the door, it's immediate, it's responsive, and the quality of the service goes up drastically, as does the ability to send a security alert. So if I've got mine set up to just send me an alert when someone walks by, well, the ability to process that image and just respond to it, because I've trained my model, if that AI is running at the edge, the quality of that service changes really drastically as well. So IoT AI ML is another use case of it seems subtle, but there's a really big difference in the quality of service that goes with moving it to the edge.
Awesome. So another one that we got was, I don't know where you can dig into this or whatnot, but how can edge computing help visualize my business in real time?
Okay, interesting one. That's not something I had thought about before. But it goes back to analytics, right? So if you've got sort of near real-time reporting or dashboards that have to do with any service or product or something you're doing inside your company, the faster that can respond, the higher the quality of service. I'll give you an example. So there's a company called Teradata that a lot of folks are probably familiar with, and Teradata has had and will have a phenomenal centralized data processing platform. And one of the things that a company called Snowflake was able to do was to bring that to the cloud itself. And so the responsiveness, the ability to move data in and out and make decisions and use those platforms really increased the velocity of that. And I think there's a lot of innovation to be had with being able to do that one step further in, which is if I can report on and monitor my business faster, more accurately at the edge, and I can consolidate data from a number of different endpoints and services and devices, I can also make my decision making faster. A great example of that is, let's say you're managing an IoT environment on a factory floor. Like I'll ignore the home for a minute, and say it's a factory floor, and you need to make decisions based on thermostats or activity. You're either going to have on-premise computing, which can be done with the modularity of our edge platform. You can use us in that way, where you can't with other service providers. But even if I wanted to run that from a public edge cloud location, like what we would offer, sitting next to somewhere in the service provider footprint, for example, that gives you the ability to, again, collect and action data much faster just because of the proximity. So really interesting one, not one I thought about before.
Thank you, Vic. All right, here's one. It's how do we protect from getting locked into an edge solution?
Oh, that's great. It's sort of the same concept of not getting locked into a cloud, right? And I think that's where our viewpoint is all around. Listen, the edge has to be agnostic. It's not about being locked in. So if you've got containerized workloads, you should be looking at multi-cloud deployments no matter what, right? It helps diversify your vendors, it diversifies the footprint, reduces the risk for your business in that model, and the edge adds another layer to that. So what I would say is really focus on your application, make it and keep it modular, and look at deploying it or the pieces of the application where it makes the most sense. Deploy things in central cloud in a diversified way, so you've got kind of call it the ability to scale and support massive workloads and sizes there, but also extend those out into the edge. And really, the edge should be a part of any multi-cloud strategy for an enterprise or business today.
Very good. All right, Arash, this is going to be our last question. I think kind of fitting with the pandemic, hopefully coming to an end. Do you think the traffic or the volume will continue on this path, or will it kind of go back to pre-pandemic volumes?
Oh, that's great. Yes, I think this is only going to get worse, and worse in a good way. So I don't think the pandemic. I think the pandemic accelerated what was already happening. So I don't think things are going to go back to a status quo afterwards. It's really, to a large degree, in my opinion, changed how we interact, how we use technology, how much we rely on it, and how much more distributed we've been. So certainly, I think there's going to be a bit of a roaring 20s, and that aspect of social life will go back to normal or even be more fun for a little while. But technology in and of itself, the rate of content consumption hasn't reduced. If you look at, companies like, my kids love Disney, right? And Disney Plus, and so do I. And if you look at their subscription numbers, they've done an amazing job growing their platform. So I really do think that the pandemic has just changed the appetite for content, access to content, and the level of quality or service that folks are expecting. And the last part of that is, I walked through a Best Buy not too long ago, and I saw, I've obviously read about the 8K TVs for a while, but I actually saw one on the showroom floor. And you think about what it's going to take to deliver 8K video content effectively and reliably to the home. Well, the only way you're going to be able to do that is with the edge. It's just not going to be possible with centralized clouds. And you look at even 4K content distribution today, it's still not the status quo. It's not standard. Certainly, many of us have TVs that support 4K, but the shift to 8K, another massive revolution. And so at some point, you're going to have to balance out infrastructure location with the ability to compress and manage data or video quality. And the edge is going to be the only way to go. So I think it's all accelerated. It's only going to be it's here to stay, and I think it's only going to get faster.
We did, if you don't mind, we did get one more question, and I think that's a good one. I think we got a little bit of time here. We got six minutes or so in our time box. Greg sent in, and he said, how can you see edge computing or serverless being used to accelerate multi-stakeholder, multi-organizational collaboration in the service of a better world?
That's good. That's a good one. That's a tough one as well. So I'll take a stab at this one. So accelerating kind of multi-stakeholder, multi-organization collaboration. I think it improves it. And here's why I say that is that collaboration platforms, and hopefully this was the intent of the question, and if I got it wrong, I apologize, but hopefully I'm close on this one, is that collaboration requires a high degree or high quality of communication. So whether you're using a communication platform like Slack or River or some other kind of tool from that standpoint, or it's Zoom, or again, any one of 10 great products and platforms that are out there, the edge is going to enable a higher quality of service in general. So just like in gaming, if my matchmaking server between, let's say Max and I are playing the latest Call of Duty on a weekend, which we've never done, but maybe someday, we're playing the application or game. The closer the proximity between my platform and Max's, the better the overall engagement, the lower the jitter, the higher the quality of video, the higher the gaming experience. And so collaboration and tools, I think we'll see the exact same benefit as more and more platforms move their services to the edge. So, telecommunications, or I call them telecommunications, but they're really video collaboration platforms like Zoom and several others are a great set of services that if they run on the edge, you're going to get a lower latency when it comes to spinning or bringing users into a conference call, because you can actually now route and then manage transit and connectivity across the edge of the network as opposed to having to go through it. And you can leverage the diverse kind of network structure that StackPath has to do that. And you couldn't do that before because you'd have to go build your own network. So really good question. Again, one I hadn't thought about at all, but I really do think there's an opportunity for collaboration tools to provide the next level of service as they port and build on the edge as well.